Hello everyone. Today I am presenting this experience on 3D printing and adding creativity, and I see it as a future of orthopedics. I am Dr. Lalit Maini. I am a professor of orthopedics at Maulana Azad Medical College. So that's a jalebi being made. That's a popular dish in North India, in which the jalebi is actually the 3D printed object. The hand of the person is the printer, and the brain is the computer and the design which we give to the printer. So this is the most simplistic way of explaining how 3D printing is done and what happens with 3D printing. So to give a better schematic diagram, you can see on this, there are two layers of diagrams. The top one shows you the traditional way of manufacturing, in which you used to subtract a design out of a block of material. And the new way is additive manufacturing, in which you just layer in and create an object. On the extreme right, you can appreciate the difference in the waste. Let's explain it the orthopedic way. So if you have to make a femur bone, if you do a subtractive manufacturing, you will take a block of material and you will chisel it out into the femoral shape. However, in additive manufacturing, you go bottom-up process and you gradually layer up the femur and practically have absolutely no wastage of material. So let's look into the basic steps to do 3D printing. If you have to start it as a hobby or start applying it into your practice, you need to choose a software. You need to do some virtual planning, make a STL file, or if you can't, you can download certain free STL files, which I'm showing you here from the internet, and practice your hobby or get to understand to know. So you need to load the printer with the spool of material. There could be various materials which could be used. And the printers which are handy, the FDM printers are like a microwave in which the material is loaded into an extruder, which is at high temperature, and it melts the plastic. You transfer your design, the STL file, to a printer by directly connecting it with your computer or through a memory stick. Once you've done that, and you enter, and the printing starts. Now, printing begins with additive manufacturing. That means it goes layer by layer. The Z-axis could be the nozzle moving up and down, or it could be the whole platform which moves in one direction and the nozzle in X and Y. So it's a easy thing to understand in this way. And if you start applying it, you will realize that it is a very useful tool which you can use in your orthopedic practice. So at the end of the day, you need a software, a hardware, which is a printer, and the material which you choose. There is some amount of post-processing which is required, and then you have the final object. Of course, you need training, you need skill and experience, which comes by using this particular technology more and more. 3D printing has gone through a huge evolution. And to start with, it was a huge sort of a setup with a very small printing area. And the difference between the normal printer and the 3D printer is this, that you print out an object which is three-dimensional and it can be used for many utilities. The most extreme application would be bioprinting, which is now a reality. And long strides have been taken in this research also, and various researchers have achieved various type of tissues which have been bioprinted. So various applications in orthopedics, they can be used for surgical planning, corrective osteotomies, in trauma, tumors, arthroplasty. It can of course be used for research, academics, and display, and doctor-patient interaction with 3D models. You can really explain to your students as well as your patients the disease you're handling, and it gives a real good understanding even to the surgical team. So here's an example how you go about the virtual planning. It starts with a CT scan in which you try to extract whatever bone you want to work on, you're interested into. Here is a patient of a chondrosarcoma of the iliac bone. And here is an MRI now. We took the CT and now we're taking the MRI images. We are marking the tumor, we're taking the soft tissue component from the MRI and extracting it and transferring it into a software where you can fuse both the CT and the MRI. So the The possibilities are immense. You can fuse MR with PET CTs, you can fuse PET CTs with CT scans, and then you can have your absolute accurate 3D model on which you can do your virtual planning as well as surgery preoperatively. So once you've got the fused model, you can easily make out the margins where the tumor exists and then mark it out using your surgical planning tools on where should be the resection margin to give you an absolute R0 resection. So you can print a 3D template, which ultimately can be used intraoperatively to guide your saw and your guide wires to do the surgical cut. So this is what has been done in this patient, in which the acetabulum could be saved and the surgery time could be reduced just because of the understanding of the whole disease which we were dealing with. The applications today's day are immense in orthopedics, from planning of complex trauma to correction of deformities to creating customized solutions for bone tumors to placing pedicle screws through guided jigs which can be printed by 3D printing to totally surgically simulate a surgery preoperatively, both virtually and on models like in the chondroblastoma shown below. So here is a video which takes you further into the future, an example of a bone tumor in which you scan the limb, you acquire the data, you plan your resection. The resection plan can then be transferred to a robotic arm, which can then use that data to do an accurate resection of the tumor intraoperatively, which allows you to give a limb sparing as well as a joint sparing surgery. The resected model can be very quickly scanned intraoperatively, and the same data can be sent for creating a solution which can be reimplanted within the OR. So the planning is transferred to an ultra-high speed printer, which creates a hydroxyapatite scaffold. It builds it up by additive manufacturing in a sterile environment, and you can reimplant it and add biologics to the whole reconstruct. And the ultimate bioprinting, this is a bioprinting video in which you use a bio ink, which is laid down according to the structure you want to make, and you can make a scaffold which has live tissue inside, the cells inside, as well as the scaffold. So evolution of bioprinting has gone a long way from the 1980s to the present structure, where people have even made human heart tissues which have been reimplanted in experimental labs. Thank you very much for your attention. And if you want to see and learn more, you can visit my YouTube channel, Ortho #609. Thank you.